solve this exponential equation. We have 3 is power 2x minus 5 equals root 9 is power x minus 3. How do we go about this? Solution. Okay, so for this we have 3 is power 2x minus 5 equals, so for root 9, instead of saying 9 is power 1 over 2, law of indices, n roots of the number, instead of saying a is power 1 over n. So here I have 1 over 2 and my exponent is x minus 3. Okay, so I want to put this in the same base, okay, to have the same base of 3. So here I have 3 is power 2x minus 5, which is equals, for 9 I can put it in index form, which is 3 is power 2, 3 times 3 is 9. Okay, so 3 is power 2 times, so for 1 it has multiplied this, I have x minus 3, 1 times x is x, minus 1 times 3 is 3, divided by 2. Okay, so this can easily cancel this. So here I have 3 is power 2x minus 5 equals 3 is power x minus 3. So I can compare the exponents. So I have 2x minus 5 equals x minus 3. Okay, so from here now I collect the like signs. I have 2x, okay, minus x equals minus 3 plus 5. So 2x minus x is x, minus 3 plus 5, I have that to be 2. So let us verify. So when we verify this, we have x, when x is 2, so let us work with the left hand side of the equation. So we have 3 raised to power 2x minus 5, which is 3 raised to power 2 times 2, okay, minus 5. So here we have 3 raised to power 2 times 2 is 4, 4 minus 5, we have to do that 3 raised to power minus 1, okay, for the left hand side. So let's work with the right hand side. So let us assume this is now this. Okay, so we have 3 into x minus 3. So we have 3 raised to power, when x is 2, we have 3 raised to power 2 minus 3 equals 3 raised to power minus 1. So both sides of the equation are equal. So the value of x is 2. The question says, solve the equation. Okay, we have 2 raised to power 3x minus 2 equals 8 raised to power x plus 1. Okay, so these are exponential equation. So when we look at this closely, we have the base here to be root 2, we have the base here to be 8, a whole number. So how do we resolve this? Solution. So for root 2, do not forget one of the law of indices. When I have n roots of a number, instead of saying a raised to power 1 over n, so when we can write this root 2, okay, as 2 raised to power 1 over 2. So when I put this in this form, so I have here 2 raised to power half, okay, times, here I have 3x minus 2 equals, for 8 I have 2 raised to power 3 into x plus 1, okay. So now I have the same base, so I can compare the exponents. So I have here 1 over 2 into 3x minus 2 equals, so I have here 3 into x plus 1. Okay, so the next step, we can open up the brackets with what we have here. So you have 1 times 3 has to be 3x, okay, minus 1 times 2 to be 2, divided by 2, okay, equals 3 times x, that is 3x, 3 times 1, we have that to be 3. Okay, so from here, because we have equal sign, we can now cross multiply. This will multiply this. So here we have 3x minus 2 times 1 equals 3x plus 3 times 2. Okay, so when you open up, you have 1 times 3 has to be 3x, minus 1 times 2 to be 2. 2 times 3x is 6x, plus 2 times 3, that is 6. So the next thing we do, we collect the like times. So here we have 3x, okay, this is coming here, we have it to be minus 6x. Here we have 6. This 2 is coming here, we have it as plus 2. Okay, so 3x minus 6x, that gives us minus 3x equals 6 plus 2, that is 8. So from here now, to find x, we can divide both sides by the coefficient of x, which is minus 3. So minus 3 minus 3. So we cancel out this. We have x equals minus 8 over 3. Solve this exponential equation. I can write it in fraction. How do I do that? I roll a straight line, the point turns to 1, the number turns to 0. So I have 5 over 10 or 1 over 2. So I can replace this with 1 over 2. So I have 1 over 2 raised to power x minus 2 equals, so for root 2, okay, I can write this as 2 raised to power half. Okay, law of indices, n roots of the number is written as a raised to power 1 over n. Okay, so when I write this in this form, I have it here, I have it in this way. So for root 2, I can write it as 2 raised to power 1 over 2 times the exponent I'm having, that is 3x plus 1. Okay, but for 1 over 2, I can write 1 over 2 as 1 over 2 raised to power 1 or 2 raised to power minus 1. Law of indices, when you have something like this, okay, it's just as saying a raised to power minus n. So when you apply this to this, for 1 over 2, I can write it as 2 raised to power minus 1, okay. We have x minus 2 equals, I have here my 2, and you multiply 1 with this, you have 3x plus 1 over 2, okay. So for this, don't forget the exponent law. When I have something like this, a raised to power n into n, I can say a raised to power, you multiply this exponent, n times n, that is nn, okay. So when you apply this to this, you have 2 raised to power minus 1 times x is minus x, minus 1 times minus 2, that is plus 2, equals 2 raised to power 3x plus 1 over 2. Now you have the same base, take it out, compare the exponents, you have a minus x plus 2 equals 3x plus 1 over 2. Okay, so from here we have equal sign, you can cross multiply, so you have a 2 into minus x plus 2 equals 1 into 3x plus 1. Okay, so when you open up with what you have here, you have 2 times minus x to be minus 2x plus 2 times 2, that is 4, 1 times 3x is 3x, plus 1 times 1 is 1. So at this point, we can collect the like signs. So here we have minus 2x, okay, minus 3x equals 1 minus 4. So minus 2x minus 3x gives us minus 5x equals, when you subtract this, you have here minus 3. So to determine x, we divide both sides by minus 5, which is the coefficient of x. This can go, this will go. We have this, we divide. So we have here x equals 3 over 5.